So in this one, we're going to talk about geometric mean versus arithmetic mean. So these means are basically the average, right? So getting the average, and we want to figure out how we can do this as it applies to our matching algorithm, which will give us percentages, right? So a percentage match, right? So if I'm X amount percent matched to you, and you are X amount percent matched to me, what's our average? That's really the question we're trying to answer here. So geometric mean versus arithmetic. Arithmetic is fairly straightforward. With the mean, you add the numbers together and then you divide it by the amount of numbers that are there and you get an average. So in this case, there's three numbers, and then if we divide it by 3, we get an average. So let's say, for instance, Apple, they had this growth of 10 million, then 12 million, then 14 million. So that's how much they grew. Every year then, on average, they grew 12 million per year. So let's look at Google. Google had, these aren't real numbers of course, but Google had percentage growth instead. So we have 2.5% growth, 3% growth, and then 3.5% growth. So the question is, can we use arithmetic here? So add those three numbers up and then divide them by 3 and get the percentage that it actually grew every year. Well, let's first off look at the actual numbers. So to get the growth, we would do whatever number it was that it starts off with. In this case, it's 100 million. So let's write that out. I'll put the commas too. So after every 30, put a comma. So we've got 100 million here that we're working with. So the actual number is 100 million, and then we times it by that growth every year. So every year it grew, the first year grew 2.5%, so that's 1.025 is how much it grew. The second year it grew 3%, so we times that number by 1.03. And then the third year it grew 3.5%, so we times that by 1.035, and we get this number of 109 million and some change. So that's essentially the actual number. So that's the real number. Now let's find out what it would be if we did this exact same calculation using the average percentage of growth using arithmetic. So if we did the average percentage of growth, we would add all the numbers together and then divide it by the number of numbers, which in this case is 3, and then we would get the percentage of being about 3%. So we would multiply this number by 3% each time, right? So every year it's 3%, so times 1.03 and so on, just like what we did with the actual. So let's go ahead and copy this, and we're going to bring it into Python. I'm going to paste this in here, and here's the number we get. So if I paste it in, put the commas in to make it a little easier to read, we see that it's about 2,600 above the actual numbers using this arithmetic. So 2,600 is significant. I mean, that's a lot of money in comparison. I mean, it's not millions, of course, but it's not the right answer. And it would be even different if the growth rates were drastically different, right? So if the percentages were drastically different, the result of actual versus arithmetic would be also drastically different. So let's take a look at the geometric mean. So what we do here is we multiply each number together, so the percentage together, and then we take it to the nth root. So if there's 3 numbers, then we take it 3 radical n, or whatever the numbers are on the inside. So to express this in exponents, we just do it to the 1/3. So to do an exponent, so like 2 squared, it'd be 2 star star 2. So that's 2 squared. 2 to the 10th power is 2 star star 10. So 2 to the 10th root would be 1 divided by 10.0, because how Python works, it will, if it's just 10, it will just round it, which is not what we want. It will round it to 1. So we've got this would be 2 to the 10th root. So if we actually calculated this in Python, it would give us this number, right? So that's 2 to the 10th root versus 2 to the 10. It's going to give us 1, right? So you want to make sure that you do that. So geometric mean this is how you actually define and calculate geometric mean, is you multiply each one of those percentages and then you take it to the nth root. So in this case we have 3 numbers, so we take it to the 3rd root, or the cubed root. All right, so since we've got this, let's go ahead and calculate this. I'm going to use it with this exactly. Paste it in here and type out geomean. And notice that is very, very close to 3%. It is super, super close. It is almost there, but it's not quite there. So we're going to continue using that, And I'll do the 100 million thing again and copy all these, paste it in. So it's taking the geometric mean each time and going through. And this is the number that we get. So let's go ahead and copy this and paste it in here. I'm going to go ahead and round this up to 125.00. And what do we got? We have the same number. Right? So that's what the geometric mean does. And the reason we're doing this has everything to do with our match percentages. So how we are going to calculate these percentages is something we'll do next. But this concept is important to understand between the arithmetic and geometric. Do realize that it is only slightly off, but slightly off done millions of times will be very, very off. Where geometric mean is not slightly off, well, the reason it's slightly off here is because of how float numbers work versus decimal numbers, which is something we'll clarify in the matching function. But this is still working, and it's there, and it's actually ready to bring us to that next level, which is actually calculating our matching function so we can prove some sort of value for our matches. If you have questions on geometric mean and arithmetic mean, please Google them. There's a lot of information about this stuff because it's rudimentary math. Of course, you could ask us too, but there's a lot of things that go behind these and theorems that have proven these to be true. But you can also do your own calculations yourself to figure out whether or not this is actually true, and it will work. But it is a concept that I'm not coming up with. It is very well proven in the field of mathematics. All right, so that's it for geometric mean and arithmetic mean. If you have any questions on how this is going to apply, please hold on to them because we're going to discuss them in the next video. All right, so we'll see you then.